Hello, and welcome to a blobby architecture tutorial, where I'm going to show you how to make blobs. And the approach that I'm gonna show you, and the workflow, I guess, that I'm gonna show you is, it's not going to give you a lot of control, but it's going to give you enough control so that you can play around with it and actually make a building out of it. So for you architects out there, listen up. So I do have a little bit of a cheat sheet here, a few notes that I already done just to see if it's gonna work, and it seems like it's gonna work. So let's begin. The first thing that I want to do is I just want to, I guess, create a test, a test piece. Let's say a ball that is going to be squished, right? So for that, I just want to create, I'll go to Mesh Tools, and I'll just create a sphere. Mesh sphere, just around the center, and let's give it, I don't know, 50 mil radius, something like that. The size of the sphere doesn't really matter, but around 50 is good enough, considering that our grid is like 100, I think. Anyway, we have our sphere. Let us reference it in as a mesh, because it is a mesh sphere. So I just reference it in, bam, bam, and I'll hide it. Oh, by the way, one thing that I did and I didn't explain, I lifted the sphere above the XY plane. Do that, please. The reason why I'm lifting it above is because we will add gravity, and our XY plane is going to work like floor, like ground, right? So as the sphere is going to be bouncing down, it's going to be squishing against the ground. So just lift it up. And I'm gonna hide it in Rhino, so just so that we only see it in Grasshopper. Okay, we managed to reference in the sphere. Next up, under Kangaroo 2, we will get ourselves a solver. Not a zombie solver, just a regular solver. And what I like doing with this is always creating a button, creating a Boolean toggle, and creating an entwine node, N-T-W-I-N-E, entwine. Actually, let me do just a second. Bifocals, yeah. I'm just gonna do a bifocals node here, just so that you can see better, what kind of nodes I'm using. Okay, so we have entwine. I connected that to goal objects. We have our reset button. That's just a button, right? And we have our toggle for turning the solver on or off. For any simulation, this is going to be like, this doesn't change. This is going to be the default. And now the light is messing up. Can we go auto? There we go. So a data tree is going to come into the solver. That means that the output from the solver is also going to be a data tree, right? So I'm just going to use bang, explode tree node, like that, and just connect it for now. And that's basically the core, the brain of the simulation. That's done. Now for the initial kind of setup or initial goals that we want to actually simulate is, well, we always start with the same one, and that is called show. Show. This one right here. And actually I could show you where it is. It's right here. Kangaroo 2 rather, the light bulb, right? That's the show. We connected to 0, 0 input of the entwine, and now the solver is going to start complaining. That's because we're not giving anything. We're not showing anything, right? So I can connect the mesh to show like that, reset, run the simulation, and the simulation is immediately going to stop and end. And the reason for that is because there's only one goal, that is show. So show goes through Entwine, goes into the solver, right? And the solver goes like, oh, I need to show this sphere. And it goes like, yep, here we go, sphere. And that's it. That's the end of the simulation, right? So it immediately tells you that it's converged, even if I reset, converged. So the output is going to come in, since show comes into 0, 0, the output is going to be at 0, 0, right here from bang. So I can just create a mesh component like that and just kind of have it somewhere here, right? This is like our final output. So now I am going to disable preview of most of these, except for the mesh at the start and mesh at the end, right? Like that. Okay, so next, what else do we want to do? What kind of other goals do we want to have? Well, the first, one of the more important ones is floor. Goal called floor. And that is going to make so that the sphere, or rather, let's add floor later. I'll show you why we are going to be adding floor in just a tiny bit. Let's do one goal first. Let's do edge lengths. Edge lengths. So the edge lengths goal, what it does, it basically takes all of the, and you can't see them, but they are there, I promise. It takes all of these edges of the mesh and it makes sure that those edges stay the same length. And now I'm fighting the camera here. So it tries to keep all of these lines of the mesh the same length, meaning that this goal will not let the mesh distort, which is quite important, right? So we are going to connect our mesh to the mesh input right here. And for the length factor, it says that it's gonna be 1. Sure, we're gonna keep it at 1. And for the strength, that's also set to 1. Let's just remember that number, you know, that we're using 1 and 1 here. If we need to, we will change it. If we don't, we won't. And this goal goes into 0, 1. If I were to reset and run the simulation, nothing really changes. That's because, you know, there's no other force that's acting on the sphere, so it just shows the sphere and it tries to keep the edges the same length as they were, and it succeeds immediately. So immediately it gets converged. Okay, more goals. Let's add some gravity maybe. So I'm going to add Vertex Loads. Vertex Loads. This one right here. Vertex Loads. Mesh connects to mesh as per usual. And Vertex Loads L output, I will actually connect it to not 0, 2 of the entwine, but 0, 1. That's because that is not 0, 1. That is because I only want 0, 0 to be disconnected from the rest, right? Only show needs to be disconnected from the rest. All other goals can come in one big happy family, right? So here we have 2 outputs and I'm only taking in or showing the second one. Or sorry, the first one, the second one is not being shown. And here we're using up only 2 inputs out of the 3. So I can even do this, right? Okay, so now this actually should start working in a weird way. So if I reset, you can't really see it, but because it goes so fast. Damn it. So you can't really see it, but once I reset, now it keeps running. And the reason why it keeps running is because this sphere, if I were to hide it, and let's look at this sphere right here, reset, so it's floating now, and now I run the simulation and it falls down, and you can see that it falls down right through this, you know, the floor. It just keeps falling, so the solver keeps running. We need to fix that, and that is where we actually use floor, like so. Strength floor, a very simple goal, which will not let our sphere fall through the grid. Like that. Perfect. Well, you know, kind of perfect. It collapses under its own weight, but it doesn't fall through, which is nice. One thing that I kind of want to do is, instead of using quads here, I want to use triangles. So I'm going to type in show selected in Rhino, and I'm going to select the sphere and type in triangulate mesh. Hit enter. It's going to become triangulated like so. I'm going to right click, set one mesh, and basically reset the initial mesh with the triangulated version of it. Hide it again, run the simulation. This should ensure a little bit better, yeah. It's a little bit more accurate of a simulation. That's basically it. We can also kind of get it even more accurate if we use Catmull Clark subdivision, for instance. If you don't have the Catmull Clark node, download Weaverbird, and then you will have it. So mesh comes into Catmull Clark, and connects, gets crumpled, you know, a little bit better. But for this particular example, I will not be using it. I will just be using a triangulated mesh. That should be good enough. Okay, so our sphere falls down on the ground. It flattens itself out because it collides with the ground, and you know, that's basically it. That's all that happens. So we want to somehow be able to control the form of the sphere, how stiff the sphere is, right? So we are going to, and I'm going to actually take a closer look. Yes, it's pressure that we want. Is it? Yes. Sorry, I had to to take a look. So we want the sphere to work more like a balloon, where it does have pressure that is not letting it crumple onto itself, right? So I'm going to add one more goal, and that's going to be under goals mesh, and I will find the one that says pressure, like that. I will connect that to the 0,1 input as well. And for the mesh, of course, I'm using the same mesh here, like that. And I believe the strength, yeah, the strength is set to be 1. If the strength is 1, it's going to be way too intense. I'm going to do 0.1 rather than 1, like that. Now, if I reset and run this, it just exploded? What? What do you mean? Let's try edge lengths 10, strength of 10, to try and keep it, you know, non-explosive. There we go. Much better. So you can see that the pressure is actually pretty damn strong, and it makes it so that the hell is it doing? No, it's fine. It's fine. It makes it so that the sphere deforms, and it deforms because of because the polygons were not the same length or not the same area size, so the pressure is unequal according to the form. That's fine. We will fix it, and actually we will fix it right now, because to move forward we do need all of the triangles of our mesh to be the same size, or at least close in the in regards to the size. So I'm going to clear values like that. I'm going to show selected, select the sphere, and actually I'm going to delete it, right? And instead of a sphere, I'm going to just draw a line like that, just a single line. And I'm going to reference it in as a curve, like that. Set one curve. I'm going to pipe it, right? I'm going to create a pipe around it. So to make a pipe, let's use the Multipipe tool that is available in Rhino 7. Multipipe. Connect curve to the curve input right here. Actually, why is this lagging? Is this lagging because, no, it's paused. Stop being awkward, stop lagging. So curve connects to curve input, that's easy. Node size, that's the radius of the curve, of the pipe. I need to, I use 10, that's fine. So I'm just gonna use 10 right here, like that. We get a pretty nice pipe, right? The reason why I use Multipipe, by the way, is if I had, let's say something like this, set multiple curves, it's gonna make a really nice connection, right? So there's absolutely no reason to use an old version of pipe. All right, so we do have this thing here. It does have open ends, so we need to cap them. I'm just going to use cap holes here, and it's going to give me a brep, right? A closed brep. That's fine. We can work with the closed brep, but I think just converting it into triangular mesh, we don't need to convert our closed brep into a mesh before making a triangular mesh out of it, because we are going to be using Remesh tool, which is also Rhino 7, a tool that's only available in Rhino 7. Remesh, like that, which asks us for geometry and target. I'm just gonna try and connect geometry to it, and it seems to be working just fine. We could try doing that. That's a bit better, I think. Is it? Let's just see. This tries to keep the end sharp. We don't really care. So I'm just going to use the same tar. Yeah, let's do it this way. It looks like shit, honestly. I mean, it does look bad, but we will make it work. Trust me. Length. For length, I'll just use the grid. Yeah, length will be around 5. Something like that. Should be okay. I'm just looking at, taking a look at how many polygons we have. I think that's reasonable. And that's basically it. We have our triangular mesh. If I connect it to the mesh input here and move the curve up, then I can reset the simulation, run it. It's just going to fall on the ground. No, nothing fancy. Okay, since you're getting bored, let's make it nicer. Now, if I were to take this curve, let's just move it down a bit, and take another one, rotate, take this whole part. Actually, let me group this whole part between curve and try remesh, and I'm just gonna make a copy of it like so, just like so. Okay. Oh, here I merged it. We'll see. We'll see if it's gonna work or not. Like that. And connect the curve component, or not connect, but reference in the curve into the curve component here. So now we have two pieces of crap going on. Let's reset and run the simulation. And now, basically what we want to do is we want this guy to interact with the bottom one, right? To basically collide with the bottom one. So how do we do that? One more goal, and that goal is the main one that for which I am actually making this tutorial, and it's called soft body collide. Soft body collide goal, where we give it a bunch of meshes, right? And see how I'm using the same mesh node over and over and over again. Very, very convenient to have just one mesh node. And everything connects to it. So soft body collide, we connect that to 0, 1. Strength is 10. I have no idea if that's good or bad. We just reset and we just take a look. And it's gonna be a little bit, like it's not gonna be as fast, but you can see, yeah, it does seem to work. Let's actually pause or stop the simulation. Let's bake this out, default, right? And let's take a look at these two pieces of crap, right? Clipping plane. So that intersection between them is still not perfectly clean, of course, because our resolution is super high. But if our resolution were to be lower, right? Or sorry, our resolution is super low. If our resolution were to be higher, then the intersection would be even better, right? So this seems to work quite well. So now we can become fancy about it, right? What would happen if we, let's reset. Oops, that's the reset button. What would happen if we created something a little bit more fancy, right? For instance, I already have prepared a few curves here, right? So I have these three groups of curves. Group 1, I'm just gonna connect it here. Set multiple. Let's just give it some time. There we go. Looks like that. Actually, we can make this smaller just so that you can see. Basically, the form is this, right? So that's group 1. Group 2. Exactly the same form, by the way. Set multiple. It's doing its thing. There we go. Hide that. And I forgot to group these, but that's group 3. So to actually get a group 3, I need to copy and paste the part of the starting part of the definition one more time. Don't forget to connect it with Shift to the mesh component here. And then once it stops crashing, there we go, set multiple curves, right? We just set it up. Give it some time, it's gonna think. There we go. So this is our geometry, right? This is something that I came up with, right? And if I were to just check real fast, 10, 10, 16. So I do think, yeah. I'll just quickly disable this just so that it's not in the way. This one right here, instead of 10, I used 16 because it's a thick boy. I wanted this one to be a thick boy. 16, like that. Oops. Change it up, so it becomes thicker, right? And also the curvature of these pipes to make them a little bit more sharper. The ends, not the end offsets, I set it to 0, and it makes it so that the piping is a little bit more sharp, right? The curvature, like this curvature, is not so loose anymore. Okay, that's it. Let's run a simulation and let's take a look at how it's gonna work. So I'm enabling the mesh, and it's not doing great. Ah, there we go. Mesh has been enabled, and I guess we just run it, right? Yeah, we just ran it. So I'm going to probably speed it up. Reset. And run. And you can see how it inflates, right? And how it basically, it's a shock wave that goes through the whole system at first because of the pressure. And now it's going to start drooping down and it's going to start simulating. So I'm not going to blab during the simulation. I'm just going to fast forward this so that you don't need to wait. Okay, that's enough. That is enough of simulating. This is how it looks like. And actually, we can even make it a bit nicer. So I'm going to hide the display. Keep in mind that instead of floor, you can use goals, collision, solid point collide, and basically get a landscape in here and make the freaking form not just fall on the flat piece of geometry, but rather on something that is curvilinear, right? And adapt to its size. But in this case, we don't really care, so I'm just having it flat. That's one thing to note. Another thing, let's make it nice. So what's a fast way of making this cool? What if we get a mesh duel? And this is where the tutorial ends. By the way, those of you who are interested in just getting this definition, consider supporting the channel over at Patreon, link in the video description. I give out all of the definitions that I make for my Patreon supporters. So if you're lazy and don't wanna follow along, just consider supporting the channel. Would be very much appreciated. Moving on. We are going to finish up here. So the initial idea is done, right? Now it's just making it pretty. By doing mesh dual, or is it dual mesh? There's dual here, but I think Veerbird has dual graph. Okay, Veerbird's dual graph. We're gonna use that. and that is going to give us a bunch of hexagons. So for every triangle, well, not for every triangle, but for every group of triangles, we get a hexagon. It's basically a dual of a triangular mesh is a hexagonal mesh. Anyway, and all of these hexagons are closed. What the hell? Why are these so messed up? No, wait. Do it this way. Don't connect it to the second input. That was my bad. So we have a crap ton of hexagons that we can actually work with this. This is gonna be a little bit rough, but I think we will manage. So I'm going to take every hexagon here and I'm going to scale it around its center point. So I'm just going to measure, no, I don't measure area, I use polygon center node, and I get the center points like so. And our factor for scaling is going to be 0.9, 90%, right? Something like that. Thus, we are getting like a frame in here. But now, what I want to do is I want to explode the initial, the starting polygons, right? And I want to explode the scaled versions, the scaled polygons as well. So I get a bunch of separate segments. And I kind of want to find, let's find some sort of a hexagon at which we can look at. Okay. So I get this separate segment, this separate segment, this separate segment, and so on, and also separate segments for the inner ones right here. So now let me hide everything else, and let's take a look at the data trees. I'll simplify them just so that it's easier to see. That seems good. And what about here? That if I simplify this, that should also be good. It is indeed good. Okay, so now I am going to get endpoints, curve endpoints. I'm basically creating a mesh, right? Recreating a mesh. I'm getting curve endpoints here and here. And now these should be, these are not in separate branches. So, sorry, before you create endpoints, you need to graft the output here and graft the output here. So now, yes, we get 1, 1, 1, 1. That's perfect. We basically, now as we will use merge, we can get 1, 2, 3, 4. Let's say these 4 points into one branch, right? Very important to do so. 1, 2. So if this is start, this is end, then this is gonna be end, and this is gonna be start. So it needs to go like so. It needs to cross here. Like that. Okay, we have a bunch of points now. Well, not a bunch, but 4 points in each branch, and we can just use construct mesh component to construct a polygon through those 4 points. Cool, huh? As long as you're following along, should be pretty simple. Now we need to reconnect all of these. We need to reconnect all of these meshes into 3 separate pieces of geometry. So I'm going to trim tree. I'm going to simplify this output, And let's see, we need to trim back by 2 steps. So these meshes are the 3 that we're trimming, and our depth is actually not 1, but rather 2. Bam. And now we should have a crap ton of polygons. Yes, we do. And now I can use combine and clean. Like that. Bada bing, bada boom. Should clean it up quite nicely. My laptop is overheating. That's not great. In your case, it should be much, much faster. I have no idea why my laptop is doing this, but by the end of it, we do have a lattice structure, a hexagonal lattice structure at our hands, which we can actually offset mesh. We can use offset mesh, or I'll be using Vertex Mesh Thicken, like that. And I am going to offset it probably inwards, right? So that is outwards, but if we use a negative distance, let's say 0.5, was that inwards? I can't tell. Yes, it is inwards. Okay, good. So we end up with having this offset, right? And this lattice structure. And now for the inner hexagons, that's gonna be pretty easy to do. All we need to do is just find where our scaled polygons were. Here they are. These guys right here. And I am just going to use discontinuity on them. So basically we just get the corner points of those scaled polygons. I will also get an average of those points. Did you know that an average of a point cloud is the center point of that point cloud? Average. I'll just get the average of those, so we get the center point, and then I'll probably just use Delone. There we go. Whew, that's a rough one. Delone mesh, like that, and just to make sure that it works for at every instance, and it's not weird in some cases. I'm going to fit plane, or plane fit it through these discontinuities and use that plane for my Delone mesh. And that's it. We get our panels. Now we can offset. Well, let's use Vertex offset mesh by, let's say, negative, like that. So if that is -1, here I'm going to use 0.5. I could just divide that slider by 2, but whatever. And then I'm going to thicken it, thicken each panel, like that. Sorry, that was a phone call. Anyway, we are thickening this bad boy up by negative 0.4, I guess. Something like that. Just getting a few panels in there. Let's take a look at the final output. Looks okay, I guess. Very separated though. we don't need it to be that separated. So I'm going to simplify it. Let's separate it in terms of the data structure. I'm going to simplify it, and I'll trim the tree, trim the data tree once. Only depth is going to be 1. Combine and clean. Clean it up. And that's it. Now this is also ready to be displayed. Custom preview. Let's just give it a little bit of a pizzazz. Gray. Like that. And custom preview for the thickness. Or the thicken, sorry. Oh my god. Okay, so apparently, the offset is messed up, right? So we can't offset properly. We need to use unify mesh normals. Unify mesh, unify mesh, unify normals. I have no idea which one is which, so I'm just going to guess. Oh yeah, that's because we're using the low noise mesh. Like that, huh? Maybe we will do it another way, in another way. Yeah, because this one doesn't help. Crap. Okay. We need to rethink this part, which kind of sucks. Okay, that was much harder than I anticipated. So basically, the way I fixed it was by getting all of the corner points from the inner polygon, inner hexagon, getting the center point, repeating the center point according to how many points we have. So for every point here, we get 1 center point. So basically 6 center points in total, and also shifting the list. So, and then merging everything together. And the way it merges is we start from the center, right? That's D1, the average, right? Goes into D1. Then we go to our just regular discontinuity, which is, let's say, this point right here, right? That goes into D2. And then we go to a shifted list, which is this point right here, right? So thus we create a triangle. And then since we are going, we're going through every corner point, right? So that triangle for this one is done. Then it goes to here, and thus it creates a bunch of triangles right here. There we go. These triangles right here. Then we trim the tree again, just for the same reason why we did it before, right here. We combine and clean it up, unify normals, blah blah blah, thicken, and now everything works and everything looks neat and dandy. So we don't need to do anything more. And that is it. Okay, that is it. That is our thing that we have, I don't know, simulated, right? And from here on out, you would start actually working with it, in Rhino, right? 3D modeling it out in Rhino. And again, this is way too, it's way too hot to do any kind of modeling. So I'm going to leave it to you to try out this technique, see, what works, what doesn't, and if it's something that you would like to pursue, right? A few more things that I want to show you, or just a few. that I kind of want to show you are, let's say if you want it to be top rendering, there we go. If you want it to be less, like if you want the shading to be nicer, you can always unweld with angle tolerance of 0. So every edge is going to become unwelded and thus will become sharp. Same thing for the inner hexagons, you can easily unweld them and make it much sharper. So now we can see the difference that it makes, right? I'm going to unweld all of these. You can do that as well in Grasshopper, by the way. No need to do it in Rhino. Let's take a look at it with Arctic view. I mean, it looks pretty cool. Kinda a nice angle. Whoop, messed it up. Kinda a nice angle here. Maybe that's gonna be a thumbnail, right? Need to get that clickbait in. But I think we are done. Let's check it with our clipping plane. That's the last thing that we're gonna do, just to see what kind of intersections do we get. Bam, like that. God damn, I love clipping planes. Come on. That's pretty cool, isn't it? I know you were skeptical at the start, but now when you're looking at this can definitely become a building. Come on. There we go. I think this is a good place to end the video. Hope you enjoyed this one, and I'll see you in the next one, which is not going to be a Grasshopper one, I promise. Yeah. Bye.